Hello everyone, welcome to Vardhaman College of Engineering. Myself Dr. Ramesh, working as Assistant Professor, Department of Chemistry. In this video we are going to discuss classification and applications of alloys. In this video we are going to discuss classification and applications of alloys. Next I am going to discuss about Alnico. Alnico is a alloy of iron, aluminium, nickel and cobalt. Here, Alnico is abbreviated as Alnico. This abbreviation is given to this one because of this alloy is made up of aluminium, nickel, cobalt along with iron, right? This is the composition of Alnico. In this, iron percentage is 40 to 70. Aluminium is 8 to 12%. 8 to 12%. Nickel is 15 to 26%. Cobalt is 5 to 24%. Along with these metals, this alloy may contains copper up to 6% and titanium 1%. Next, properties of Alnico. Alnico alloy shows strong magnetic properties and high ferromagnetism. These alloys acts as magnets and having useful magnetic properties at red hot temperatures, that is the range what 500 to 800 degrees centigrade. This is the range of red hot temperature. At this temperature, Alnico alloys acting as magnets and gives useful magnetic properties, right? And Alnico alloy shows electrical conductivity also. This is not happened in the case of ceramic magnets. Alnico magnets have the property of electronic conductivity. This is not happened in the case of ceramic magnets. Alnico alloys have very good resistance to corrosion. Alnico alloys shows very good resistance to the corrosion. Next, applications of Alnico alloys. Alnico alloys used as strong permanent magnets, used to manufacture of microphones, electric guitar pickups, electric motors, loudspeakers, traveling wave tubes, and Hall effect sensors, etc. Right? Alnico speakers are favorite of many musicians, as are they known to produce the best tone and also respond quickly. Alnico speakers are favorite for many musicians because of these Alnico alloys response is very quickly and gives a good tone, right? Alnico speakers are best for jazz, blues and mellow rock. These are the applications of Alnico alloys. Here, see this image. In this image, this is what speakers, this is guitar pickups and other things which are made by Alnico alloys. Next one is nichrome. Nichrome also comes under ferrous alloys. Nichrome is made up of nickel, chromium, manganese, iron. Nickel, chromium, manganese, iron. Nichrome. Nickel, chromium, manganese, iron. Nichrome is an alloy of nickel, chromium, manganese and iron. This is a composition of nichrome. Nickel 60 to 80%, chromium 15 to 20%, manganese 1 to 2%, iron percentage is 26. Next, properties of nichrome. Nichrome is consistently silvery gray in color. Its color is silvery gray. It shows corrosion resistance and has high melting point, about 1400 degrees centigrade. It's having high melting point, that is what, 1400 degrees centigrade, and its color is silvery gray, right? It shows corrosion resistance, right? Nichrome alloys are known for their high mechanical strength. These alloys having high mechanical strength, right? Next, these are shows high strength, high ductility, high resistance to oxidation. High resistance to oxidation, nothing but resistance to the corrosion, right? Next, stability at high temperatures. These alloys can bear high temperatures also, and also resistance to the flow of electrons. Resistance to the flow of electrons means what? These are acting as insulators. There is no conductivity. In the case of Alnico alloys are acting as conductors. Those are acting as what? Those are shows conductivity. Alnico alloys shows conductivity, but in the case of nichrome, it is not shows conductivity. In this case, resistance to flow of electrons. These alloys are resistance to flow of electrons. Then we can say that these are acting as insulators, right? Next, applications of nichrome. Nichrome is widely used in electric heating elements like hair dryers, water heaters, right? Next, heat guns. Nichrome can be used in the explosive and firework industry as a bridge wire in electric ignition systems. Bridge wire, nothing but fuse wire. It is used as a fuse wire or bridge wire in firework industry systems, right? Industries. Hot wire foam cutters also. In hot wire foam cutters also, nichrome wire is used, right? And also, nichrome can be used in ceramic as an internal support structure. Nichrome wires are used in ceramic industry as a internal support structures. And nichrome alloys or nichrome wire which can stand at high temperatures. That is the reason why this is used in clay work, clay work is fired in a kiln. Due to this property, or nichrome alloys or nichrome can withstand at high temperatures. Due to this reason, nichrome wire or nichrome alloy used in clay work which is fired in a kiln, right? These are the applications of nichrome, right? So far, we have discussed ferrous alloys. Under ferrous alloys, we have discussed stainless steel, alnico, nichrome, and their properties and applications, right? Now we are going to discuss non-ferrous alloys. Non-ferrous alloys means in these alloys there is no iron metal. Without iron metal, alloys are non-ferrous alloys, right? Non-ferrous alloys are brass, bronze, and solders. Brass, bronze, and solders, right? Here, iron is not there in these alloys, right? First one is solder. Solder is a word which is derived from the Latin word solidare. Solder, word which is derived from the Latin word solidare. Solidare means to make solids. Here, this alloy shows low melting point comparing with the constant metals. And here the idea of using low melting point alloys to bind to similar or dissimilar metals was introduced 1000 years back, right? But today's solders is typically a blend of tin, lead, and or flux. The idea of low melting point alloys to combine similar or non-similar materials was introduced 1000 years ago. But today's solders are typically blended with tin and lead or flux, right? Composition of solder: lead 37%, tin 63%. This is what tin and lead mixture allows for solder with a lower melting point than two metals being bonded. Here, the alloy of solder melting point is less, that is what, 183 degrees centigrade, right? But the constant metals melting point is more comparing with the solder, right? So, this reason this alloy is used to bond. Alloy is used to bonding of similar or dissimilar materials or metals, right? Similar or dissimilar metals or metals, right? Right. Once again, let me repeat. This is the alloy of lead and tin. The melting point of solder is less comparing with the constant metals. Those are what? Lead and tin. Due to this reason, this alloy is used to bind the dissimilar or similar metals at low temperature, right? Because of its low melting point. Next, properties. These alloys possesses high fusibility, high oxidation and corrosion resistance. These are also shows high oxidation and corrosion resistance. The melting range of these alloys is 180 to 190 degrees centigrade. Applications of solders. Solders are used in metalworking technique, right? Metalworking technique, and also having applications in jewelry making, plumbing, electronics manufacturing. Let me repeat, applications of solders. Solders are used in metalworking and jewelry making, plumbing, electronic manufacturing. This is about solders. Next one is branch. Branch is an alloy of copper and tin. The percentage of copper is 88 and tin is 12%, right? Along with these two metals, branch may also contain manganese, aluminium, nickel, phosphorus, silicon, arsenic or zinc. Along with copper and tin, branch may also contain manganese, aluminium, nickel, phosphorus, silicon, arsenic or zinc, right? Next, properties of branch. Branch is looking like what? Golden in color and golden color hard substance. Branch is usually a golden hard brittle metal. Branch is usually a gold hard brittle metal, and the properties of branch depends on its specific composition, right, and how it is processed. The properties of branch depends on the specific composition of branch as well as how the branch is processed, right? Here, the characteristics of branch. It shows high ductility, exhibits low friction against the other metals. Branch alloys displays the unusual property of expanding. Due to this unusual property of expanding, branch is used for making sculpture casting. Branch is used for sculpture casting. This is desirable as it helps to fill a mold. Branch is helped to fill a mold, right? Next, unlike steel, when steel is collide with other steel, that may get what? Spark. If steel is collide with other steel material, we may get spark, right? Right. But in the case of branch, branch when collide with other materials, or when branch collide with others other metal surface, there is no spark, right? It won't generate sparks, right? When bronze is collide with surface of other metals, won't generate sparks, right? Due to this reason, bronze materials are used in flammable or explosive used as flammable or explosive materials. Due to this property, due to non-sparking property, bronze is used as a material in inflammable and explosive materials, right? Like inflammable or explosive materials are rounded by bronze only, right? Next, applications of bronze. Bronze is used in architecture for structural and design elements. Bronze is used in architecture for structural and design elements. For bearings because of its friction properties, and phosphor bronze is used in musical instruments, electrical contacts, and ship propellers. Aluminium bronze is used to make machine tools and some bearings. Aluminium based bronze is used to make machine tools and some bearings. Next, bronze is also used to make coins. Most of the coins are made with copper based bronze. Actually, coin contains copper with 4% of tin and 1% of zinc, right? Bronze has been used since ancient times to make sculptures. This image shows this is what sculpture, right? Next, these are the materials which are made by bronze, right? Right. That medals also made by what? Bronze medal is there, right? Gold, silver, and bronze. 3 types of medals are there in the games, right? That is what bronze is made up of: copper, tin, and 1% of zinc, right? Next one is brass. Brass is also non-ferrous alloy. Brass is an alloy made up of copper and zinc. The proportions of the copper and zinc are varied to yield many different kinds of brass. To prepare different kinds of brasses, we need to change the proportions of the copper and zinc, right? The basic modern brass is with 67% copper and 33% zinc, right? The amount of copper may range from 55 to 95, right? Next, the amount of zinc is varying from 5 to 45%, right? Lead metal is commonly added to brass at a concentration of around 2% to improve the machinability of brass. Lead is also added. What percentage? 2% of lead. 2% of lead is added to the brass to increase its machinability, right? Next, properties of brass. Brass is a bright gold. Brass has bright gold appearance. However, it can also be reddish gold or silvery white. The high percentage of copper yields rosy tone brass, right? If the percentage of zinc is more, it is appeared as silver in color, right? Next, brass exhibits low friction, good conductor of heat and high malleability. Brass also shows resistance to the corrosion, including galvanic corrosion from salt water also. If you place the brass in salt water, it won't get corroded because of it has resistance to the corrosion. even galvanic corrosion also, right? Brass is not ferromagnetic. Due to this ferromagnetism, we can separate brass material from other materials, right, by recycling process. Brass is not ferromagnetic. Due to this reason, we can separate brass material from other metals by recycling process. Applications of brass. Brass is acting as a what? It is a bactericidal material, or it has bactericidal property, right? Due to this property, in marine environment, it is used to prevent the biofouling. Biofouling means accumulation of microorganisms. See this diagram. This ship is inside the seawater, right? In the case of this one, we may get biofouling, right? On the ship, accumulation of microorganisms maybe takes place. We can prevent that biofouling by the usage of what? By the usage of brass material. If this marine structure is coated with brass or made by brass material, we may prevent the biofouling, right? This shows antimicrobial property. This antimicrobial property, action by copper and its alloys is, the antimicrobial property of copper and alloys have been studying since 100 years, right? Or the mechanism of antimicrobial property of copper and its alloys, including brass, are a subject intense and ongoing investigation. The research has been going on the mechanism of antimicrobial property of copper and its alloys along with brass also, right? Brass is used in making of musical instruments. Musical instruments are made up of brass. Brass also used to make musical instruments, radiators, right? Pipes and tubings, screws, decorative items, and firearm cartridge casings. Brass is used to making music instruments, radiators, pipes, tubing, screws, decorative items, and firearm cartridge casings, right? This image shows that is what marine environment or marine structure. These are the musical instruments which are made by brass. These are the applications of brass. So far we have discussed non-ferrous alloys. Under non-ferrous alloys we have discussed solders, branch, brass and their properties and applications, right? This is about non-ferrous alloys. In this whole video, we have covered classification of alloys, that is what ferrous alloys, non-ferrous alloys. Under ferrous alloys, stainless steel, alnico, nichrome have completed, and under non-ferrous alloys, we have completed solders, branch, brass and their properties and applications. Thank you very much.